Hi teachers, this is a model remote lesson for second grade science pushes and pulls. I'm going to demonstrate how to utilize the CTLS Learn system in Zoom meetings along with Hello Smart technology to enhance your digital lesson. To begin, we're going to click on our digital session and go live to meet our students. Good afternoon, scientists. How are you today? I'm so excited to see you because we have a wonderful lesson about force and motion today. And we don't have that much time live today, so we're going to jump right into it, okay? So you guys remember how to use the Hello Smart Lab that we used last week. So what I'm going to do is I have already given you our class code in the chat, but I want you to go ahead and navigate to your Google Chrome browser and type in Hello Smart, and here is the class code. I'm going to share it with you. All right, this is what you're going to see, guys. I want you to go ahead and navigate to hellosmart.com and enter this class code 712626. Once you got that, you will see our lesson on your screen. I'll know when you're here because I will see my number pop up so I can make sure that everyone's here. And if you have a question or you're having trouble getting to hellosmart.com, go ahead and raise your hand in Zoom and I will be able to help you. All right, about 10 more seconds and we'll have everyone here so we can start our pushes and pulls lesson. Today's lesson is going to be teacher paced, so you can follow along with me. There are going to be several times that you can interact inside of the lesson and you'll see that response notification pop up on your screen. So we're going to go ahead and get started. Let's look at our learning target today. You know that we have been looking at standard S2P2, which is obtain, evaluate, and communicate information to demonstrate changes in speed and direction using a force. We're going to focus on the very first element today, which is plan and carry out an investigation to demonstrate how pushing and pulling on an object affects the motion. For today, our learning target is going to be I can explain how force, pushes, and pulls can be used to do work. So we have that word explain, that's our verbs. And when we're unpacking this learning target and this standard, we know that you have to be able to tell someone, you have to explain how force can be used to do work today. All right, let's get into it. Let's talk about yesterday. Oh, we had so much fun yesterday looking at that walking table phenomenon. I mean, I had never seen a table that could walk before, but we talked about this really important scientific word called gravity. This vocabulary word was super important because we talked about how it's a force that brings objects down to the ground. We also listened to a really, really fun book called I Fall Down. And within that book, there were so many little mini experiments that you could do at home. And you had a Flipgrid assignment last night where you recorded a short video of you showing and demonstrating the force of gravity. And I checked all those out and you guys did a great job. I even left you some feedback for you to see. So today we're going to look at a different phenomenon and we're going to do a 3-2 wonder and you're going to do a see, think, wonder guiding question for me. But we're going to watch this really cool short video clip and we're only going to watch it for about 10 seconds, but I want you to 3, 2, wonder. That means you're going to stop everything and you're going to give this video clip your undivided attention. I just want you to check out everything that's going on. All right, so we're going to do that right now. Let me get this full screen for you. All righty, so we did that. Now it's time for you guys to do a 3-2 wonder guiding question. All right, I'm gonna start this for us, and I want you on your device that you're at right now, I want you to look at that prompt. We have I see, I think, I wonder, and our evidence. I want you to go ahead and fill out one of these. I want you to give me one response for any of our columns. Tell me what you see, what you think, what you wonder. I'm gonna give you guys, let's see, I'm gonna give you about a minute timer. Here we go. Ooh, we have some people. Kat sees lights flashing, bells, pinball. Karen sees a pinball going everywhere very fast. Johanna sees a ball being hit from one place to another. Absolutely. Right. Very good. I saw lots of bright flashing lights, but I saw that ball going everywhere really, really fast. I saw everything that you did. Did anybody else see the piece that the player that was playing the pinball machine held to make that ball go up? I don't know if anybody saw that. We're gonna watch it again a little bit later and tomorrow to see if we can see that too. All right, so I want you to start thinking, we saw all of this action going on, all of that movement, all of these different forces. When we come back to our chart a little bit later, we're gonna add to the I think or the I wonder side, all right? So you're right, you guys wrote that it was a pinball. You're absolutely right. A pinball is a machine. It's an arcade game machine, but let's switch gears and think about all the machines that we have in our house and what those machines do and how they use force and motion. All right, so in this picture of this really fancy kitchen, it must be a scientist's kitchen, you see a bunch of different machines, right? What do we think all of these machines have in common? Let's take the first one. We have a little toaster over here. What does a toaster do? Well, it toasts bread, right? Or anything else you want to put in there. But it has mechanisms on that to help it do a job. What does that bread do when the toaster is done? Pop! It pops out, right? Something's gonna push that bread out, right? What about that dishwasher? There's something inside that dishwasher that sprays water all over those dirty dishes. And it helps us get those dishes done, right? We have to work in order for us to get our dishes clean. That machine helps us do the work. What about the oven and the microwave? I want you to think right now in your head, what work does an oven help us do? What kind of push and pull motions do we have to do in order to work an oven? Do we have to open the door by pulling the door? Do we have to push the food in the casserole dishes or the pizza that we're trying to make? We have to use all of these motions, and these machines help us do the work. So all of these machines help us do work. That's what they all have in common. Check this out. This is my dad. I was at my dad's house this weekend, and he was building a little bookshelf for my daughter, right? And he's using tools to help him do the work. He's actually screwing in a screw into a piece of wood. What is that drill helping him do? Is he pushing that screw in, or is he pulling something out? Well, he's using the push force, right? He's pushing that down, and that tool, that drill, is helping him do that work. All right, so here's the fun part. All right, make sure you have plenty of space. We're gonna pretend that we're a simple machine doing work. I have a picture of a shovel right there, and we're gonna pretend that we are gonna plant a tree, and we're using that shovel to dig our hole, right? We have to do several different movements in order to make sure that that shovel makes that hole big enough for our tree. So I want you to take your arms. You know what? This might be better. I'm gonna stop sharing for a second so you can see me. Here we go. So I want everybody to take your arms like you're holding a shovel. Great, good job. Make sure you're looking at me. Good. And you're going to push that shovel down in the ground, and you're gonna lift that dirt, and you're gonna toss it, right? All right, so we have push, lift, toss. Do it one more time. I wanna see you guys do it by yourself. Ready, go, beat the shovel. Push, lift, toss. Very good. So I would love for Johanna, could you unmute yourself and tell me what force I'm using when I use that shovel? What am I doing? Uh-oh, she must have frozen. We'll go first there. Oh, I'm sorry, what was that?
You're pushing.
That's right, we're pushing, right? And when we lift, it's almost like we're pulling, right? Very good. Look at this, I have a ball. One of my kids' squeezy balls that I have here, all right? So we know gravity does this. What's gonna happen when I drop the ball? Gravity is gonna make it do what? Right? Can I also push the ball to make it move? What do you guys think? Thumbs up, thumbs down. I can push the ball to make it move, right? What if I had a toy car? Here's my son's Lego car, right? In order to get it to move from one place to the next, what do I have to do? I have to push it, right? Just like when you're outside playing with your toys. What about also, okay, we did a shovel, we did a ball, we did a little Lego car. What about if you're on a swing in the playground? What do you need to do? What forces do you need to use? Say you're behind your friend. What are you gonna have to do to make them go up in the air? Katie, can you help me with that one?
Yes, I would have to push my friend to get them to go.
Right. If we want to change direction, we're gonna have to do that. And remember when you're on the swing and you're having that, let's see who can go the highest with your friends. That was always my favorite, right? What did you do with your legs when you're trying to get yourself to go higher? Are you kicking your legs slow or fast? I see Johanna, yeah, you're
fast.
Your legs. You're kind of going fast, right? So speed of the push or the pull also affects your direction. Okay, I'm gonna reshare my screen and we're gonna get back into it. Now that we've talked about the difference between pushes and pulls, and we've talked about how machines help us do work, right? And work is something that we do in order to get things done and to help us with force. We're gonna do something really cool. Here's what I want you to do. I want you, scientists, my little scientists, I want you to go in your house or wherever you are. I want you to find something, a machine, an object that can help you do work. And then I want you to come back and I want you to write it on our Shout It Out board. Okay, I'm gonna give you a minute. Now remember, safety is important. If your parent is there and you want to look at something in the kitchen or that's a tool or something, please ask their permission first. Safety is important, so go find something around your house that helps you do work and then come shout it out back on our board. Ready? Go. Scissors. Yes, yes, yes. All right, scientists, you have about 30 seconds left. Awesome job. Okay, seems like everyone's back. So far we have scissors, pencil sharpener, and a spatula for flipping pancakes. All right, let's talk about these. Scissors. Everyone do your hand motion, scissors, right? What force are we using when we're doing work with our scissors? We are pushing and pulling our fingers back and forth, right? To make that. What about a pencil sharpener? Pencil sharpener, what kind of force do we have to use in order to make the pencil sharpener do work? We're pushing our pencil in. Very good. And a spatula for flipping pancakes. Oh, I just had the best blueberry pancakes last weekend. But that spatula is helping us do what? Flip those pancakes. It's helping us do work. And we are pulling those pancakes out of the pan. Very, very good. Good job, guys. All right, now this is something you're gonna do individually on your own device right now, but it's called a super sort, and we are gonna sort our aliens. You know me, you know I'm a space nerd. We're on Mars today, and what you see, those aliens, they have pictures of objects, and they're either being pushed or pulled. I want you to take, you guys are gonna get 1 minute to sort these pictures into the correct alien flying saucer. Go ahead and do that for me now. For those that need help with the pictures, you have a bird pulling a worm. Looks like you have a camper and a trailer, a car, a fisherman, a teddy bear, and a wagon. Looks like a doctor, a farmer, a person, and a mom and a baby, and a librarian. All right, scientists, you got about 15 seconds left. All right, good job. If you need extra time, just let me know. Raise your hand in the on Zoom for me if you need extra time. If not, looks like everyone was able to do that sort. Awesome job. I will give you feedback later on that sort. All right, so here is what we're going to do today. On your work session time today, you are gonna read an article about pushes and pulls, and it's super engaging, and you're gonna see another amazing scientist talk to you about different things that he uses the force of motion with. You're going to, after you read the article, you're gonna answer some questions for that, and then you have one more thing to do. I would like for you to go to Flipgrid and record a response to the following question. What is work? And explain how machines help us do work. Let me go ahead and show you how to access these resources. I'm gonna stop sharing my screen, and I am going to take you to, actually, I'm gonna take you back to, I'm gonna take you over here. Nope, wrong one. Here. All right, so in our digital session, you're gonna click on here. You joined our live classroom here. This is giving you the step-by-step of what I expect of you today, scientists. Here's your guiding questions. This is what we did today, and your lesson resources are going to be right here. Here is your article, Pushes and Pulls. Here is your question, and this is the link to the Flipgrid. So it's all right here for you. Again, if you have any questions, please, please, please let me know once you get started. And I am going to be giving you feedback on that flip code, and that will be, we will talk about that tomorrow. So let's go back to we have our guiding question board, right? And we were looking at that pinball machine, that digital phenomena, and we were trying to think about what was happening in that video and what we can figure out about it, and if we can actually give some evidence to support what we think, right? So tomorrow when we get together, we're gonna fill out the I think and the our evidence portion of this guiding question board. So I want you to be thinking tonight. We're gonna talk about work, we're gonna talk about force and motion, we're gonna talk about specifically pushes and pulls, and how pushes and pulls help that pinball machine work, okay? So that's all for our session today. If you have any questions, please reach out to me, and I will hang out for just a few minutes for anybody if they have questions. All right, guys. Looks good. So we will see you tomorrow for the next science lesson on pushes and pulls. Thanks. Have fun doing your activity.